Hello everyone, myself Dr. Kouser, Assistant Professor of Computer Science. Welcome you all to session 8 of System Software and Operating Systems course. The session 8 is on first type of loaders called the compile and go loaders, and we also learn about the general loading scheme. In the session 7, we have learned about what loaders are and why loaders came into existence, and we also learned about the four important functions which are performed by all loaders, and we also learnt about various types of loaders. Now let us move on to the first type of loader, that is the compile and go loader, which is also called assemble and go loader. In this loading scheme, the assembler itself does the compilation and then loads the assembled instructions in the designated locations. Then instructions are read line by line, and then its machine code is generated and directly put the machine code in the main memory at some known address. In this loading scheme, the assembler runs in one part of the memory, and the assembled machine instructions and data is directly put into their assigned memory locations. Here no object code is generated. Source program is directly converted to the exe code or the executable code. So in this figure 8.1, we see the compile and go loading scheme. The source program deck obtained from the pass2 of assembler is input to the compile and go loader, which for example into a translator like assembler, then which is input into finally the source program deck information is then loaded into the memory. Okay, you can see the program that is loaded into memory in the memory part, and you can also see the memory is occupied by assembler also. So this space which is occupied by the assembler is wasted in this type of loading scheme. So coming to the advantages and disadvantage of this compile and go loader. The advantage is that this scheme is pretty simple to implement, and because assembler is placed in one part of the memory, and loader has to simply load the assembled machine instructions into memory. Now coming to the disadvantages, which are many when compared to the advantages of compile and go loaders. So here the first disadvantage is because the assembler occupies some memory, there is obviously memory wastage, and this amount of memory is unavailable to object program, which could have been utilized by the object program. And this scheme is a combination of assembler and loader, so it occupies a large block of memory. Another disadvantage is even retranslation has to be performed at the user's program deck for every execution, even if there is no modification in the source program, because there is no object file creation in this type of loading scheme. And coming to the language, it is very difficult to handle source programs that are in different languages. If entire source program is in one language, then this type of loading scheme is manageable, but if there are different languages involved in the source program, then it becomes very difficult. This is because assembler can translate one source language to another target language. And because of all this, even the execution time gets increased, or it is more, because every time program is assembled, only then it can be executed. Now moving on to the general loading scheme. Here the general loading scheme came into existence to avoid the disadvantages of compile and go scheme. Here the size of the loader is smaller than the assembler, and more memory is available to the user because the core is not occupied by the assembler. Reassembly is not required to run the program at later date, as it loads only the object deck. Finally, the problem of source program in different languages is automatically handled here, because the object deck or the object program is always in a single language, that is in the machine code. In this figure 8.2, we can understand the general loading scheme. Here you can have two different source programs which are fed into a translator like assembler, and you get two different object programs which are output from two assemblers, and these two are taken by the loader, which then loads it into the memory for execution. Here you can see that no longer assembler is part of the memory. Here in the memory you can see that it is occupied by loader and then the object programs which are ready for execution. Hence, this general loading scheme avoids some of the disadvantages of the previous loading scheme, that is the compile and go loading scheme. Here the memory utilization as well as the time spent for retranslation is avoided. Hence, this is a better loading scheme when compared to the compile and go loading scheme. Thank you all for your patient listening.